Hello, class. For today, I'm going to give you a little bit of a quiz review and continuation of the probability sections that we have been talking about. Now, tomorrow I'm not going to post any videos because you guys will be just strictly be working on the assessment. It will be about 3 questions, and you guys just have to write down the answers and then just submit it to me. And that will be your first quiz grade for the new marking period 4. All right, so you will see questions as of the following, and I'm going to give you some homework assessments at the end that I still would like you to finish. I would like you to take a very close attention, pay close attention to these questions because most likely they're going to be following the same suit. This week, the very first thing that we did was we found out a probability when we're talking about geometric shapes like this. So don't be surprised that when you have a rectangular shape with a triangle, the area formula is not going to be given to you. You have to figure that out on your own. Even if I were to give you a circle with even a little circle inside, which we call concentric circles, you need to be able to find out the area of this circle and the area of the larger circle and so forth, and you get the idea. So what is the probability that a random leaf, you don't really have to ask questions why they decided to do random leaf, but lands on the on the rectangle that lands within a section shaped like a trapezoid. So what we're talking about is we're talking about this particular portion of the rectangle and what is going to be the probability, right? Now there are really 2 ways in which you can do this. Number one is that you can use the area of a trapezoid formula, which if you were to look up online, it says that it's h over 2 times base 1 plus base 2. And there will be a variations of that. Or what you could do is that you could take the area of the rectangle and then you could subtract away the area of the triangle, because if you were to take this shape, rectangle, and then if you were to subtract this part away from that rectangle, you will get the rest of it, which is pretty much what we're looking for, right? So you could do it this way or you could do it this way. It doesn't really matter which way. I would prefer to do this one because it just makes it a lot easier for me to think about rather than me having to memorize a separate formula. Area of a rectangle. Now, please understand that the length of this entire rectangle is 9 because it's 3 plus 6. So that's 9 times 5, because the length times width would be 9 times 5, which is 45. So minus the area of a triangle, which is 1/2 base times height. Please don't forget that. 1/2 5 times 6, because that's the triangle right there. That would be minus 15, so the area would be 30. Now, you're not done there yet because we're talking about the probability. So the probability of this, you would think that it's 30 out of the entire area of the rectangle, which we already have it right here. It's out of 45. Reduced it down to 2/3. Okay? The probability, so that if we were supposed to land somewhere here, we're going to be getting approximately 67%, or give or take, that the leaf will land on that trapezoid shape. Now, if you're asking me, Mr. Kim, which answer would you prefer? Either one of these would be fine. This one would still be okay, but I would still prefer if you prefer the reduced version of it. Number 2, I would like you guys to pause the video and then take a look at the question and then try solving this on your own, and then take a look at the video once again. Okay, so for number 2, it says there are 5 red tiles and there are 5 blue tiles with the letter A in the back. So it's a little bit complicated because not only do we have different colors, but different letters as well, A and B. There are 6 red tiles and 4 blue tiles in the back. So let's think about this. How many red tiles do we have? 11 red tiles. And how many blue tiles do we have? We have 5 plus 4, which is 9 blue tiles. All in all, we have a total of 20 tiles. And it seems that the letter, we have 10 letter A cards and 10 letter B cards. What is the probability that a randomly selected tile is blue or has the letter B? So first of all, your selection of choosing blue would be coming from here. Your selection of choosing letter B would be coming from here. But the problem is that, is this a mutually exclusive or not? Well, the problem here is that there could be a blue card with a letter B. There is an overlap, right? There are some cards in the middle that both belongs in the category blue and B. So if you think about the previous couple of slides, the formula that I've given you, this is a non-mutually exclusive event because there's an overlap. So if I want to find out the probability of A or B, the probability of that is probability of A plus probability of B minus probability of A and B happening at the same time. So that is what I'm going to apply here. So probability of A or B, in other case, the A is the event that is blue. Event B is the event that is letter B, is equal to probability of just finding blue plus probability of B, which is just finding letter B, and you subtract away probability of A and B, they both being blue and letter B. So first, let's consider this. The first one is what is the probability of you being able to find the blue card? Well, that's 9 out of 20 because that's the category right there that deals with color. The second portion, it deals with the letters. And with the letters, it's probability of you finding letter B out of these 20 tiles that we have. So that's 10 out of 20. But the problem is, if you just add these two up, then you're counting that overlapping part twice. So you want to subtract once away. So the probability of both A and B happening at the same time, that is both blue and letter B, which is this 4, because there are 4 blue tiles with letter B. So that's 4 out of 10 in which you want to counteract against counting it twice. So once you do that, your final answer should be, that should be 20. 15 out of 20 reduced it down to 3/4. Okay? Now, part A was the OR situation. Part B was the AND situation. What is the probability that a randomly selected tile is red and has the letter A? Well, that is the probability of red and letter A. So you want both of them to be happening at the same time. Remember, this is non-mutually exclusive event, which means there's going to be some overlap. When we're talking about red and letter A, we're talking about really the first sentence right there. How many red tiles, that's also letter A? Well, that's 5. And out of total number of cards, which is 20, reduced it to 1/4. Okay? Okay, so for last question for today, and after that, I would like you to solve these questions on your own. You have 6 questions to solve for. These questions are going to be, I'm not going to tell you whether they're mutually exclusive or non-mutually exclusive. But I hope you understand what I mean by that when I say if it's not replaced. If it's not replaced, it means you pick one card and then for the second one, you don't replace it, so your denominator should change. Okay, so I'll help you with number 7, but before that, let me just do this first. So remember, these 3 questions, 1, 2, and 5, I would really like you to work on these questions and make sure you guys understand how to do them. Find the probabilities to complete sentences. Leave your answer in terms of decimal, no rounding. The probability that Yuri will make a free throw is 0.3. So what does that mean? It means that out of 10 free throws that Yuri has, 3 of those he or she will make. 7 out of 10 of those, the complement of that, Yuri will make the shot, right? So you need to first find the complement of the probability. I think I gave you the example of the free throw yesterday as well. So now, the probability that he will make, he will make 2 consecutive free throws. So, what is your probability of making the first free throw? 3 out of 10. What's your probability of making the second free throw? It's 3 out of 10. Because these two, the first free throw has nothing to do with the second free throw. We call these 2 events independent. Oh, what if Yuri got tired on the second free throw? No, we're not going to think so outside the box like that. We are simply going to assume that whether he makes it or not on the first shot, has significantly no impact on the second shot. Let's say that if the person makes the free throw the first time around, then suddenly this basketball hoop suddenly gets taller by 10%. It grows by 10%. As long as you make the shot. then your context changes, right? Your environment changes, so your probability of the second one is directly impacted whether you make the first shot or not. But we're not even talking about those crazy scenarios. We're talking about the same basketball hoop, and you're making the shot over and over and over again, which doesn't change the environment, the surroundings. It's still going to be the same. So the probability that he will make 2 consecutive free throws is simply 3 out of 10 for the first time, 3 out of 10 for the second time. And what do you do with these two? You multiply them. Remember, if it's an independent event, the probability of A and B happening is probability of A times probability of B. What is it in this case? The probability of A is making the first free throw. Probability of B is making the second free throw. If they are both making it, the probability of A and B, in other words, they're both making 2 free throws, is the probability of A times probability of B. So it's 3 out of 10 times 3 out of 10, which would give you 9 out of 100. The probability that he will make the first and not the second in the 2 free throws is, okay, so that's again probability of A and B. Notice the word and. So what that means is probability of A times probability of B, once again, because they're independent events, but notice how he will make the first, but not the second. So the probability that he makes the first one, as we have already know, it's 3 out of 10. But what's the probability he doesn't make the second one? Well, we find that out in the complement, right? And so that will be 3 times 7, 21 out of 100. Take a look at this and pause the video and try to solve this on your own. And play it again once you're ready. I hope you have your answer to be 49 out of 100, because that neither of the 2 free throws is made is 7 out of 10 times another 7 out of 10. So 7 times 7 should give you 49. Okay? Now, for the last questions, these are going to be the same type of questions that I would like you to solve for. 10 yellow, 6 green, 9 orange, and 5 red cards. Once a card is selected, it is now replaced. Find each probability. The probability that you find the 2 yellow cards, but notice that it is not replaced, guys. So the probability that you pick the first yellow card is what? Well, the first yellow card is 10 out of this entire number of cards, which should be 15, 5, 20, that should be 30. So it's 10 out of 30, right? But what about the second yellow card? Now think about it. This card, you picked one. So how many yellow cards is in the deck? You should have 9 yellow cards in the deck, and it's not replaced. That's the magic keyword here. It is not replaced. So what that means is on the second trial, I only have 9 selections to choose from, but in the end, my total number of cards in the deck is, it's not 30, it's going to be 29. Because I have selected that card away from the deck of cards. That card is in the pocket or wherever it's thrown away. It's not there. So after you do these, then you take these 2 and multiply them. So you should get 90 out of 870, which you should be able to reduce it. Okay, so hope this video helped, and make sure you finish 1, 2, 3, 4, 5 questions to do. And I'll see you guys tomorrow. Remember, no video tomorrow. This would be sort of like your review guide. And take a look at the video if you're confused about anything. I'm going to make it very similar to these 3 questions you have up here. Make sure you have your notes. It's going to be open notes, obviously, because I can't have you guys check for academic integrity during these difficult times. So just finish up the quiz ASAP and just submit it to me by tomorrow. For today, your homework will be these 5 questions. Thank you and have a good day.